0.5. Translate this instance to this. Oh, sorry. Let me select again this instance, this data point towards this one. Okay, the other will create instance and add this beam. Rotate. About Y 90 degree. Okay. Okay, to assemble this part properly, let's do one thing. Create data point from this corner and offset from this corner towards Z. It move down, that is minus 0.03 and in Z 0.03. Okay. Then translate this beam select this data point and move towards this. Okay, then this properly assembled. Next, go to step module, create step dynamic explicit, then time period 0.2. Then in field output request, edit this, the default one. Go to here in this list, go to this failure and fracture, then it's compressive damage and tensile damage there, then check this box. Okay, you can increase this interval to reduce the running time, evenly spaced time interval, then click OK. Then go to interaction. Okay, one thing I have left in assembly, we forget on the impactor. Let's assemble it. Add this impactor. Select this point at the bottom of the impactor, then select this midway point. Okay, then in property module, let's back to this impactor. We'll create one reference point. First, create a data point between 2 points. Select this 2 point and this data point is created. Then go to reference and select this datum point, and we created a reference point. So everything is okay. Let's go to interaction, create interaction, surface to surface contact explicit in initial step. Then go to master surface, select this surface. So we have two options here. One is magenta color and the other is brown, the bottom one. So when you see this type of problem, we have this surface will contact with the top surface of the beam. So if you mistakenly select the magenta, it will not work. So be careful when you select this surface. So the bottom surface, that is brown, will contact with that of the top surface of the beam. So select surface. So slab surface is top surface. Then let's click this contact interaction property. Select contact as this default name, and in mechanical tangential select this static kinematic exponentially kg 0.4, then 0.2 and 2. Click OK. Then connect with this. Then go to this constraint manager and create select one embedded region, click continue. Let's choose this display group option, then part instance, and let's remove this impactor and beam. Remove this part, then select the whole part. Okay, then region, then go to here, add, and select the beam. Okay, so see, leave as a default. Then embedded region, that means embedded region, this reinforcement material will inside, so the force we apply on the concrete will directly transfer to that part that is into the reinforcement material. So go to other coupling constraints there. Let's draw one part here. Go to beam. Or let as it is. You can create a partition. Vertical and on the right, select this part, put this horizontal dimension 0.1 and distance from this end is 0.1. Put the same think in this direction, then dimension 0.1. okay, then from this 0.1 distance and click OK. Then let's create a datum point between this point and between these 2 points. Okay, then go to reference point as this at datum point, similarly. Reference point, sorry, let's go to this module. Let delete or let go to here in interaction, then tool reference point and select this datum point. Okay. Okay, I've created this. One is that's embedded region. Those reinforcement steel bar are embedded into the concrete. And constraint one is coupling. That is one reference point is there, and couple those parameters, the bottom concrete onto this. Then constraint 3 for the other side. So these two parts will use as a support for lateral analysis. Then go to load. So in load, in this boundary condition, create displacement rotation initial. Select this reference point. Okay, this beam is one is the roller support, and in another direction you will have fixed support. So for fixed support, fix all this except one direction. Okay, then go to displacement rotation, select the other reference point, constraint all degree of freedom except X direction and in Z rotation. Displacement rotation, this reference point, constraint all this degree of freedom except U2, that is this will drop downward in Y direction from 10 meter height. So go to this predefined field initial velocity mechanical, then go to this, select this reference point. Type is uniform, that's distribution uniform, that's translational only. There is no rotational moment, so put 14.8 we have, that's a minus, that will move downward. So in interaction manager, let's go add one thing in special, just special inertia, then create inertia and put point mass. Select this reference point and then put this 3 kilogram object. This impactor will have this 3 kilogram mass and will drop on this concrete. Okay, then go to mesh, impart, put a global size 0.2, maybe 0.02. Select structural as it is and mesh, then go to here, select the part and select this explicit 3D stress and go down here. We have one hourglass control, select enhanced and distortion control, yes, and use the default length ratio as it is 0.1. For impactor 0.02. Mesh, it's actually district rigid, but you can put as explicit. Then rebar, for the sake of compatibility we use the same global mesh size. Mesh it and assign this material explicit beam as it is, that's B31. Zero 0.02 as it is, then mesh it. So for this rebar bottom and rebar top, we have this one is actually truss. Okay, and for rebar top, assign this material truss T3 D2. Then save, let's save it. Select working directory, just desktop. Save this. Then create job. Concrete beam. Then go to this polarization and increase this multiple processor up to 4 at least, and select this double analysis, then okay, then submit this analysis and we'll wait for result.